Hello and welcome to Algebra 2 Practice Set 26. In this video, we're going to look at some additional practice problems for our lesson on solving systems of linear equations by substitution. All right, so we want to solve each linear system using substitution. All right, so for the first problem we're going to look at, we have negative 4x plus 8y equals 8, and then x minus 8y equals 4. So what I'm going to do is I'm going to label this as equation 1, and I'm going to label this as equation 2, just for the purposes of being able to refer to things. So I look at equation 2, and I notice that x there has a coefficient of 1. If you have a variable that has a coefficient of 1 or negative 1, it's usually easiest to start with that. So I'm going to start by solving equation 2 for x. So I have x minus 8y equals 4. So how easy is it to solve for x? I just add 8y to both sides of the equation. And so this would cancel. I'll have x is equal to, we'll have 8y plus 4. So let me write this over here, that x is equal to 8y plus 4. Now when we use substitution, what we're going to do is, we're going to substitute in for x in the other equation. So I started with equation 2, so I'm going to substitute in for x in equation 1. Now what am I going to be substituting in? Well, x equals, or x is the same as 8y plus 4. So I can take 8y plus 4 and substitute that in for x, and I'll have a linear equation in one variable. So I'll have negative 4 times, this is a quantity that represents x, so I'm going to use parentheses. So 8y plus 4, again, just plugging that in for x, then plus 8y equals 8. So now I have a linear equation in one variable. So I'm just going to solve that. So negative 4 times 8y is negative 32y. Negative 4 times 4 is negative 16. Then plus 8y, and this equals 8. So when we look at this, negative 32y plus 8y is going to give me negative 24y. Then minus 16 equals 8. So then I want to add 16 to each side of the equation. This is canceled. I'll have negative 24y is equal to 8 plus 16 is 24. All right, so let's scroll down and get some room going. So if I divide both sides of the equation by negative 24, this would cancel with this, and I'll have y is equal to 24 over negative 24 is negative 1. So I know that y equals negative 1. I still don't know the value for x, so let's erase everything. So as an ordered pair, I'd have something, comma, negative 1. So what I can do, since negative 1 is the solution for y in my system, that means that the y here would be negative 1, and the y here would be negative 1 as well. So I can plug a negative 1 in for y in either original equation. Let's go ahead and use equation number 2, because that one looks easier. So we have x minus 8 times negative 1, just plugging that in for y. This equals 4. So x, negative 8 times negative 1 is 8. This equals 4. So I would subtract 8 away from each side of the equation. This would cancel, and I'll have x is equal to 4 minus 8 is negative 4. So I have an x value of negative 4 and a y value of negative 1, or the ordered pair negative 4 comma negative 1. So let's erase this, and we want to check this now. And to check it, we're just going to plug a negative 4 in for each x, a negative 1 in for each y, and see if the lefts and the right sides are equal. So we'd have negative 4 times x, I've got a negative 4 for x, plus 8 times I've got a negative 1 for y, and this equals 8. So negative 4 times negative 4 is 16, and then 8 times negative 1 is negative 8. So 16 minus 8 should equal 8, and of course it does, right? You get 8 equals 8. So this works out. Let's erase this now. So I have x minus 8y equals 4. So I'm going to plug in a negative 4 for x, and I'm going to plug in a negative 1 for y. So I'd have negative 4 minus 8 times negative 1 is equal to 4. So I'd have negative 4. Then negative 8 times negative 1 is 8. So plus 8 equals 4. And of course, negative 4 plus 8 is 4. You get 4 equals 4. So yeah, it works out as a solution there as well. The ordered pair negative 4 comma negative 1 is the solution for this system. All right, for the next problem, I have negative 2x plus 3y equals 4, and then negative 8x plus 8y equals 0. So let's call this equation 1, in this equation 2. And let's go ahead and solve equation 2 for y. Normally, again, you look for a variable that is a coefficient of 1 or -1. We don't have that here. So I'm just going to solve equation 2 for y. So we have negative 8x plus 8y equals 0. So let me add 8x to both sides of the equation. So that would cancel. You'll have 8y is equal to 8x. So all I'm going to do is divide both sides of the equation by 8. So this cancels, and this cancels, and I'll have that y is equal to x. So y is equal to x. So they are the same value. All right, so let's erase everything. Now, we worked with equation 2. So I want to plug in for y in equation 1. So that's right here. And I'm going to plug in a value of x. Because y is equal to x, y is the same as x. So essentially, I will have that negative 2x plus 3. Plug in an x for y because they're the same. So plus 3 times x equals 4. So essentially what I have is negative 2x plus 3x, which is x, and that equals 4. So my solution for x is 4. So the ordered pair will start out with a value of 4 for x. And I already know that x and y are the same, so I should already know that the y value is 4 as well, right? Well, let's test out that theory. Let's say we have negative 8 times 4 plus 8y equals 0. If I solve for y, negative 8 times 4 is negative 32 plus 8y equals 0. Add 32 to both sides. That'll cancel. You'll have 8y is equal to 32. And of course, if I divide both sides of the equation by 8, I will get that y is equal to 4, right? Which is exactly what I said there. Let me leave this up because it's going to make it easy for us to check. Let me just plug in a 4 for y real quick, and I'll check the second one. Negative 8 times 4 is negative 32. 8 times 4 is positive 32. Negative 32 plus positive 32 is 0, right? 0 equals 0. So we verified that one. For the first one, you have negative 2 times x, so times 4, plus 3 times 4, and this should equal 4. Negative 2 times 4 is negative 8, so you'd have negative 8 plus 3 times 4 is 12. This should equal 4. So you'd have 4 equals 4. So it works out there as well. Let's take a look at another one. So we have negative 10/3 x minus 8/3 y is equal to negative 4/3. And then we have 5/2 x plus 2y equals 2. So I'm going to label this as equation 1, and I'm going to label this as equation 2. So what do I want to do here to start? Well, I can multiply both sides of this equation by 3 just to make it cleaner. So if I do that, all the denominators would cancel, right? If I multiply this by 3 and this side by 3, I would have what? Negative 10 times x minus 8y equals negative 4. So let's erase this and say this is this now. For this one, I can get rid of this denominator of 2 by multiplying both sides of the equation by 2. So 2 times 5/2 would be 5, then times x plus 2 times 2y is 4y, and this equals 2 times 2 is 4. All right. So now that we have it in a cleaner, more compact format, let me kind of copy these, and let me bring them down here. Let me scroll down and get a little room going. And what I like to do when I have fractions is just get rid of them and start with 2 new equations without fractions. So this is 1, and then this is 2. All right, so now that we have that settled, we don't have a variable with a coefficient of 1 or negative 1. So what I'm going to do is I'm just going to pick equation 2, and I'm going to solve it for y. So we have 5x plus 4y equals 4. Let me subtract 5x away from each side of the equation. That'll cancel. I'll have 4y is equal to negative 5x plus 4. So let me divide both sides by 4. That'll cancel. We'll have y is equal to negative 5/4 x plus 4 over 4 is 1. So now that I have what y is equal to, I can plug in for y in equation 1. Right? Y is equal to this negative 5/4 x plus 1. So this is going to go up here. All right, so let me erase all of this, and I'll do this off to the side. We'd have negative 10x minus 8 times this quantity that I'm plugging in for y, which is negative 5/4 x plus 1, and this should equal negative 4. All right, so let me erase this. I don't need any of this anymore. Let me kind of drag this over here. All right, now we're ready to go. So we have negative 10x, just going to copy that. Negative 8 times negative 5/4. Negative times negative is positive. 8 divided by 4 is 2. 2 times 5 is 10. So plus 10 times x. Negative 8 times 1 is minus 8. This equals negative 4. Uh-oh, we have a problem. Negative 10x plus 10x is 0. This would cancel. I'm left with negative 8 equals negative 4. That's false. This is false. So what did we say in the lesson? When the variable drops out and you're left with a nonsensical statement, like negative 8 equals negative 4, you know that you have no solution, right? These two lines are parallel to each other. So there is no solution. No solution. You can put the symbol for the null or empty set. Now, you can prove this to yourself. Let me erase all this, and I'll go back and actually show you how you can tell that they are parallel lines. And basically, all you need to do is solve each original equation for y. So let me go back up here. Again, I put that there was no solution. And I just want to prove that to you real quick. So if I have negative 10/3 x minus 8/3 y equals negative 4/3. And I said, hey, solve this for y. What would I get? I would have plus 10/3 x on each side of the equation. That would cancel. I would have negative 8/3 y is equal to 10/3 x minus 4/3. Now to get y by itself, I could multiply by the reciprocal of negative 8/3. So that's negative 3/8. And I do that on both sides. So this would cancel, of course. And I would have y is equal to negative 3/8 times 10/3. The negative 3 in the 3 would become negative 1. So you'd have negative 10 over 8. Negative 10 over 8. And we know that negative 10 over 8 would reduce to negative 5/4. So this is negative 5/4 times x. And then negative 3/8 times negative 4/3. The negative times the negative would be a positive. 3 over 3 is 1. 4 over 8 is 1/2. All right, so that's the first one solved for y. And I'll just kind of drag this to the side real quick. All right, if I solve this one for y, I could subtract 5/2 x away from each side of the equation. So that would cancel. You'd have 2y is equal to negative 5/2 x plus 2. Now, because there's a fraction here, the easy way to think about this is I'm going to multiply both sides by 1/2. So what's that going to give me? Well, this cancels, and so I'll have y is equal to, if I have 1/2 times negative 5/2. Well, I know that it's going to be negative, and then 1 times 5 is 5, 2 times 2 is 4. So negative 5/4 times x, and then 1/2 times 2 would be 1, so plus 1. Now, what do I notice here when these two equations are solved for y? Well, what I notice is that they have the same slope, negative 5/4, different y-intercepts. This one occurs at 0, 1/2. This one occurs at 0, 1. So if I have the same slope and different y-intercepts, I know I have parallel lines. And if I'm working with a system of linear equations, they're never going to intersect, so there's no solution. These are parallel lines. All right, for the last problem, we have negative 12x minus 14y equals 50. And then 3x plus 5y equals negative 14. So again, I'm going to label these. This is equation 1. This is going to be equation 2. There's no variable that has a coefficient of 1 or negative 1. So I'm just going to start out with equation 1. I'm going to go ahead and just solve it for x. So we have negative 12x minus 14y equals 50. So let's add 14y to each side of the equation. This is going to cancel. we'll have negative 12x is equal to, we have 14y plus 50. So let's divide both sides of the equation by negative 12. And so this is going to cancel with this. We'll have x is equal to, what's 14 over negative 12? I know it's negative. They're each divisible by 2. 14 divided by 2 is 7. 12 divided by 2 is 6. So negative 7, 6 times y. 50 over negative 12. I know that's negative. And they're each divisible by 2. 50 divided by 2 is 25. 12 divided by 2 is 6. So this is over 6. Now 25 is 5 times 5. 6 is 3 times 2. So nothing else I can do there. And again, I've solved equation 1 for x. So I'm going to plug in for x in equation 2. So this is what x is equal to. So we're going to plug that in there. So we're going to have 3 times this quantity. We have negative 76y minus 25, 6, then plus 5y equals negative 14. Let me erase this. We don't need it anymore. 3 times negative 7 over 6. 3 and 6, we think about 6 canceling with 3 and give me 2. So this would be negative 7 over 2 times y. Then I'd have 3 times negative 25 over 6. So I know that's negative. The 6 would cancel with the 3 again, so that would be a 2 down here. And then I'd have a 25 in the numerator. Then we have plus 5y equals negative 14. So the easy thing to do here is just to clear that denominator of a 2 from each of these. So I'm going to multiply both sides of the equation by 2. Get rid of that. 2 times negative 7 halves is negative 7, then times y. 2 times negative 25 halves is minus 25. Plus 2 times 5y is 10y. This equals 2 times negative 14 is negative 28. So now negative 7y plus 10y is 3y. Then minus 25 equals negative 28. So let me add 25 to each side of the equation. That'll cancel. We'll have 3y is equal to, negative 28 plus 25 is negative 3. Divide both sides by 3, and you get y is equal to negative 1. So this is the ordered pair, something comma negative 1. All right, so now I can plug negative 1 in for y in either original equation, either 1 or 2, see what I would get for x. Let's go ahead and use 2. That equation looks a little simpler, so we'd have 3x plus 5 times negative 1 equals negative 14. 5 times negative 1 is negative 5, so you'd have 3x minus 5 equals negative 14. Let's add 5 to each side of the equation. So that'll cancel. What we'll have is 3x is equal to, negative 14 plus 5 is negative 9. So we'll divide both sides by 3, and we'll get that x is equal to negative 3. So the x value here would be negative 3. The y value is negative 1. So let's keep this one in place real quick so we can check it really quickly. So for x, I'm plugging in a negative 3. Of course, 3 times negative 3 is negative 9. 5 times negative 1 is negative 5. So negative 9 minus 5 is negative 14. Right? You get negative 14 equals negative 14. So this ordered pair works in this equation. Let's check equation 1. So we have negative 12 times x, again, x is negative 3, minus 14 times y is negative 1, and this equals 50. Negative 12 times negative 3 is 36. Negative 14 times negative 1 is plus 14, and this equals 50. 36 plus 14 is 50. So you get 50 is equal to 50. So yeah, it works out in this equation as well. So we can say this ordered pair negative 3 comma negative 1 is the solution for our system.